Hello everyone and welcome to video 16 of this machine learning course. Today we are going to be learning about the dot product in Numpy, okay? So without wasting any more time, we're going to launch our Jupyter notebook and start learning about Numpy's dot product. So let's get on to that. Okay, so first what we do is we go to search and search up Anaconda prompt if you are in Windows, or you search up terminal if you are in Mac or Linux. So I'm going to search up Anaconda prompt and it'll come up with this, and also if you have a terminal it'll come up with something similar. Okay, so first you need to know how to set up your environment. I'm not going to cover that now because that's a long process, so please set up your environment first before you start writing these commands. So as always, we need to activate our environment by saying conda activate, and we put in the specified file path. So that is what I'm going to do. Desktop folders, ML course, tab to autocomplete. Okay, so once we press enter, this base over here should turn into this path. Okay, it should turn into that path, and it did. So now we type in Jupyter Notebook and it should start up. Yep, it is right now. Okay, so now we've got our homepage. So what you want to do is you want to navigate to your practice notebook so you can start coding. See when I have actually done that. Okay, so this is where we left off last time. And as I told you today, we are learning about the dot product, but in the previous video, we learned about reshaping and transposing. Today, we'll be thinking a bit more about when we'll be using transposing, and we'll also be learning about the dot product in as well. So in Markdown, I am going to write dot product because we are learning about a dot product. It's not part of manipulating and comparing. We're just going to learn about the dot product. So first we're going to create two matrices, but we're also going to use the, so first we're going to create a random seed actually. So np.random.seed, let's just set it to 0. We're going to create two matrices, so mat1 is equal to np.random.randint. Let's say we'll do up to 10, so numbers up to 10, and let's set the size is equal to 5, 3. We're also going to create another matrix called mat2. So np.random.randint again. I want values up to 10, and the size will be 5, 3. Okay, so we've got two matrices. Okay, so no errors there. Let's look at matrix 1. Okay, so random values, maybe pseudo random values, keep them in mind. So we've got those two matrices, they are working fine. So let's check this shape. I mean, we already know the shape, but we are just going to keep it here for reference. So mat1.shape, and we also want mat2.shape. Okay, so that is what we want. Okay, and we got our two shapes in a tuple. So now, let's try and multiply mat1 and mat2 together. So or we could so we can multiply mat1 and mat we can multiply mat1 and mat2 element wise. Okay, so we got that. Let's view these two matrices. So let's call mat1 and let's also call mat2, and we will have them over here. So basically this first value is basically 5 times 6, that's 30, and so are the others. Okay, so now if you're listening out, I said I said a word that I've never said before during this machine learning. I said this word was element wise. Okay, so element wise multiplication. Yeah, so that is what it's called, or you can also call it a Hadamard. You can also call it a Hadamard product. Okay, so let's actually search up what that means. Okay, so let's search up what that means. Okay, so here is Google. So what we need to search up is the Hadamard product Numpy. Enter. We need to correct that, don't we? So here is Numpy Dot Multiply. Okay, so that is Numpy Dot Multiply is basically element-wise multiplication. Okay, so yeah, so Numpy Dot Multiply, it multiplies arguments element-wise. Okay, so that is element-wise multiplication. Okay, so that is what it is. And yeah, so that is what we're going to be looking at today. And we're also going to be looking at the dot product. Obviously, that's our main concept. So let's actually run some code before we start understanding it. So we're going to run some code about dot product. So let's actually search that up by saying numpy dot product. So we've got numpy dot dot. So what does it do? It's the dot product of two arrays, specifically, not very useful. If both A and B are one-dimensional arrays, it's inner product of vectors without complex conjugation. Okay, so that's not actually it's not that useful. So we're not gonna talk about that a lot. We're just gonna focus on it, and I'll explain it to you later. So np dot dot mat1 and mat2. Okay, so here it's saying shapes 5, 3 and 5, 3 are not aligned. 3 dimension 1 is not equal to 5 dimension 0. What could this actually mean? Okay, so what could this mean? Have a think about that, and I'll explain it to you in a few seconds. Okay, so if you thought about it, well done. If you have, you'll see if those are correct, if your thoughts are correct in a moment. Otherwise, if you haven't thought of anything, don't worry, I'm just about to show it to you right now. Okay, so here we are. We are going to be looking at this mostly, so this will kind of get you understanding. So this is dot product versus element-wise multiplication, okay? So this is what element-wise multiplication looks like. So let's say we've got our array A, B, C, D multiplied by E, F, G, H. So these two arrays multiply by each other. The first result over here, so if I just get the pointer up, this first result over here is basically A times E. So the result, the product of A and E is this result up here. And then the result over here is the product of F and B. C and G is, so this result is C multiplied by G. This result is D multiplied by H. So element-wise multiplication is pretty easy to understand since you can just use this asterisk symbol. It's not too confusing. It's pretty simple actually. But here we've got the dot product, okay? So the dot product, we have, let's say we've got this array over here, and we multiply it by this array, okay? So we say this array dot dot, and we put in this array, it will equal to this. So the first result would be a times j plus b times L plus c times n. So what it has done is it has multiplied the first row of this array by the first column. Okay, so that actually might be quite hard to visualize. So let's look at a more colorful representation. Okay, so this is much better. So we have got A, B, C, and J, L, N. So A times J plus B times L plus C times N, and that is this result over here. You could work it out like this, but we'll just keep it like that for the moment being. So what we got? So look at this pattern over here. It says the numbers on the inside must match. So it's got 3, 3, and 3 and 2. Okay, so the new size is the same as the outside numbers. So this new size is the outside numbers, so 3 and 2, and the numbers on the inside must match in order to use numpy's dot dot. Okay. So if we look at it with an actual actual numpy, like with actual numbers, we can see that this result over here is so we've got 5 times 4, that is 20, and then 0 times 6, which is 0, and 3 times 8, which is 24, and if you add all of them together, you get 44 altogether. Okay, so this first result would be equal to 44, and remember these outer let's just wait for this thing to get out of the way. Okay, so this is let's just wait for it. Okay, so this outer result over here, this blue 3 is this blue 3 and this blue 2 is the actual shape of this result array. Okay, so that is what it is. If you'd like to look at a live representation, what we're going to do is we are going to get up a new window. So new window over here, and what you can do is you can let's actually search up here. You can search up I think it must be, so what do you need to search up is matrix multiplication dot x y z, and if you press enter, it says matrix multiplication, and we have actually got this representation, and this is known as the waterfall technique. You can change these numbers if you like, but we're not going to do it, and it will show you the dot, what happens during the dot product. Okay, so let's zoom in here so you guys can see. So if we press multiply, this is gone on to the top. Okay, so next, so it has slid down, and we've got our 1 times 2 plus the 2 times 6 plus 1 times 1, and that is the first result, which is equal to 15. It goes back down again. And then we've got the next two results. So these bits represent the next two results. So this and this. And then next it slides down. That's the next two results. And again, this is the last result. Okay, so you could actually play around with it a few times. So you could change the numbers, like, I don't know. If we change the numbers, we can change it to 1. Let's say 2. Actually, no. Actually, oh my goodness. So we could change it to 0, 2, 4, 6, 8, 10, and then another 0, 2, 4, 6, 8, 10, and then another one, 0, 2, 4, and then you could do it again just to get more understanding. So look at this on top of here. Next, we have got 0 times 6 plus 2 times 10 plus 4 times 2, that is equal to 28. Slides down, we have got 6, the next two results. And then we've got the next two results and the next two results. Okay, so this is why it's called the waterfall technique. Okay, so if we go back to this slide, if you don't understand, you can write it out handwritten like this and just look at it and write a few more examples, and you will gradually, slowly start getting the understanding. Because don't worry if you don't get it at first, because the dot product is such a hard topic. Loads of people, including me, don't understand it at all. And I still don't understand a bit, but I did a bit of practice and it worked. So let's get back to our Jupyter notebook. Okay, so here we are. And now let's actually start thinking about how we can make this work. So we need to make these two align. So we need to make 5, 3. We need to make it to be aligned like 3, 5. So we've got mat 1. We need mat 2 to be like this. So think about how can we actually let that happen. So have a little think about some previous videos, what we did. Okay, so have you finished? If you have, it is actually pretty simple, and this is where we can use the transpose, okay? So we are going to transpose map 2 so we can swap the axes around, okay? So if you want to remind yourself about NumPy's transpose, what we want to do is obviously you want to transpose mat 2. If you want to remind yourself of what this does, we need to say transpose. What does it do? It flips the axes around. Okay, so that is exactly what we want it to do. So if we say mat2 dot capital T, okay, so but we will still want to check this shape to see if it works. So mat 2 dot T dot shape. Okay, so it's giving us 3, 5, and that is exactly what we wanted up here. So I guess we can say mat 3 is equal to np dot dot, and we want to do mat 1, and we want to pass in mat 2 dot t. Okay, and if we run this now and we ask for mat 3, we get this array. So now it has worked. And if you want to know what happened, write it visually, see what you can do. Try look at some more, a bit more at the waterfall technique, and you will get it. Okay. So also if we look at mat 3 dot shape, there we go. We've got 5, 5, and that's what we wanted because remember, so we wanted mat 1 to be 5, 3, and we wanted mat 2 to be 3, 5. and these outer numbers together will equal this. So beautiful. You guys have learnt about the dot product. So please practice a bit more and you'll certainly get it if you practice, okay? So guys, well done for learning about the dot product today. If you have any comments or doubts on this topic, please please comment in the comment section below. I'll put the link if you would like that dot product presentation. You guys can look at it a bit more if you want to understand. And if you like this video, please like and subscribe. And I guess that's the end of this video. Bye!